In this video, I will demonstrate how to use this matrix multiplication template with 5 risky assets. So, beginning with step 1, I will calculate returns. And copy and paste. Excess returns are the periodic return minus the mean return. Put absolute cell on the row but not the column, and then I can copy it all through the green. Variance covariance matrix comes from this formula. Excess returns are in green. And again. And we can count any of these rows that have the right number of periods, and then Control Shift Enter to fill in the variance covariance matrix. We'll estimate 20% in each of the weights. Make sure that our sum formula is capturing them all. And then we're ready to enter the variance using this formula. Weights are in orange. Variance covariance matrix is in blue. And weights again in orange. And again, this is an array formula, so Control Shift Enter. Standard deviation is the square root of variance, and we can use sum product for the returns. Looking at the weights and the average returns. Notice that we now have 5 stocks plotted on the return risk plot over here. Kellogg, the lowest risk and lowest return, Walmart, the highest risk and highest return, and 3 others in between. So now we're ready to use Solver for these different scenarios. Let's begin with the minimum return portfolio by changing the weights, keeping them at 100%. So using Solver, our objective is the return, which we want to minimize by changing the weights, keeping the sum of the weights equal to 100%. And as expected, it puts 100% of the portfolio in the lowest return stock. We can copy and paste as values. Now let's do the highest return. Everything is the same except we want to maximize our objective. And it puts 100% in the highest return stock. Now let's do the minimum variance. This time our objective is variance. We want to minimize it by changing the weights, keeping the sum of those weights equal to 100%. We can copy and paste as values on the line that we've designated as the minimized variance by changing the weights. The remaining lines to be filled in are to fill in the points along the blue curve in between. We can really pick any return we'd like between 3.8 and 6.7%, and then a couple more between 6.7 and 14.8. So I'll start with about 4.9. This time I want to minimize the variance by changing the weights, keeping them summed to 100%, but I want to add a constraint that says the return will be equal to 4.9%. By doing so, I ensure that my point is going to end up in the chart at 4.9%, and the furthest left I can be with that combination of stocks by minimizing the standard deviation or the variance. So we'll copy that row, paste it as values, and choose another one. This time let's use 10%. Now let's use 12%. So we'll change the return constraint to 12%. And then let's go with 14% for the last one. Notice that when we look at the efficient frontier, we were able to drastically reduce the risk in our portfolio from that of any of the stocks that make it up, while maintaining a significant amount of the return. And that's the whole point of portfolio optimization. Let's take another look at what's happening with the various stocks as we try to seek a greater return. Obviously, at the lowest return, we have 100% in the lowest stock. At the highest return, we have 100% in the highest returning stock. And in between, it's a little bit gradual. Obviously, Kellogg diminishes from 100% to 0% monotonically, and Walmart increases monotonically from 0 to 100% as we move up the return axis. What's very interesting is that at the points of lower risk, we see a use for IBM stock and ExxonMobil stock. What's also interesting is that nowhere in these optimizations did we find a use for AT&T stock. AT&T stock has a relatively high risk for a relatively low return, and none of our optimizations chose to use any AT&T stock.